Hi there. Today we're going to do a deep dive demonstration into CloudEOS, both for multi-cloud and for cloud-native applications. I'm joined today with Fred Schill.
Hi, Doug.
Hey, Fred.
So what I'm going to do here is we're going to stand up a bunch of things in the public cloud, as well as interconnect these clouds to my data center on-prem Kubernetes cluster.
So connecting Amazon East, West, Azure, Google, and an on-premises environment together.
That's right. And we're going to segment things so that we're going to have a dev, a prod, and a test segment, which are only going to be able to talk to other dev, prod, and test segments.
Across multiple clouds and on-premises environments all at once.
Yes. And
Super
all
cool.
securely through IPsec using VXLAN and EVPN to separate everything.
All right. Well, show me the magic. Show me how this works.
All right. So now the first thing I'm going to do is actually deploy this, and I'm going to use Terraform to deploy all of this stuff.
Why did you choose Terraform?
Because it seems to be the tool that most cloud operators are using. So It seems to be the most friendly DevOps tool for your cloud guys.
And this is the step that I think you call declarative provisioning?
Absolutely. So it is a very declarative based templating language. So you're going to kind of just say what you want it to do, and it's going to take care of all of the hard work in the back end for you.
Now, how do you tell it what to do in the networking side with Arista, EOS, and CloudVision?
Yeah, so we've actually built a Terraform provider that will allow Terraform to talk directly to CloudVision. We put in about 8 lines of template code into the Terraform script, and then once Terraform starts hitting that part of the script, it's just going to execute everything for you.
Can you show me those 8 lines?
Yeah.
I'd love to see what that looks like.
Yeah, sure. So let me just pop over here to another terminal.
Sure.
And
because I just want to have an idea when you say declaratively provision an entire network with 8 lines of code, what those 8 lines actually do.
Yeah, so let's bring up the template here.
Sure.
It's actually going to keep complaining.
It always does help to tab to a new window sometimes, right?
Yeah. So just got to get my directory. There we go.
Gotcha. Nice work.
Yeah. So here is my template, and we will skim through here and pull up our module code here. So here you can see these few lines here are basically declaring that this new VPC that I'm creating is going to be a leaf, the CIDR block that's assigned to it, and our CNPS identifier to tell us what segment we're going to be part of in this particular VPC.
And you even define the topology in the architecture, in this case a flow fabric.
Exactly. So
Super cool.
Just a few lines here, and it's going to take care of all the hard work.
So when it reads this, it says deploy a 2-tier fabric fully interconnected between sort of the cloud leaf and the cloud spine.
Mm-hmm.
Deploy these cloud leaves that are peering as its interconnection method, direct peering, or it could use TGW or IGW or something like that as an alternative.
That's right.
Okay.
Yeah.
And then use this particular CIDR block, and this segment is going to be called prod.
Exactly.
Okay, I got it. So you're saying go do this, and what we're seeing in the background is Terraform doing that.
Exactly.
Okay.
Through the provider that we have that allows it to work with CloudVision.
Awesome. So how do I know it's really happening then?
So let's go take a look at some dashboards here. So the first dashboard I'm going to pull up is this new MultiCloud Dashboard we have in CloudVision. And what this is letting me do is see what the network looks like across multiple clouds. So here you see what we've got in AWS. So here are my VPCs, the VPC ID, the CIDR block that we assigned that you saw in that Terraform template earlier, the tag that's been assigned to that. So here it's prod. And then if I scroll down, you can see that this is consistent across all of these different clouds. So in Azure, I've also got my network stood up.
And there are VNets in Azure.
In VNets in Azure, VPCs in Google, and my on-prem cluster as well. So I get a nice, clean, unified dashboard as to what the network looks like across all of these different clouds.
And CIDR block, segment, and then whether the router is CloudEOS or not at the edge.
Exactly.
Okay.
So if we go back to this diagram here, so what we've just done is we've deployed about a half dozen new VPCs in AWS West. And again, we've assigned 2 of them to be dev, 2 of them to be prod, and 2 of them to be test.
Okay.
What's more is we also are tagging the resources in Amazon as well. So for the cloud guys who are coming in and trying to see what's going on, they can actually search on things that have been tagged with the CNPS of prod, and they can see all the resources that are assigned to the prod segment.
So my Cloud Eng team can declare the topology, my Cloud Ops team can monitor to make sure everything's coming up, and the same tagging structure used in the cloud environment is what's used for the Layer 3 VXLAN identifier, which is what's used in the on-premises environment. And the same tagging structure is coherent between the cloud operator and the network operator's worldview?
Exactly.
Okay.
Yeah. So we want to make sure everybody has the same view into the same information.
That's awesome.
So if I select dev here, I get a different set of resources.
What's the status check initializing? What's that?
So this just means that these virtual EOS or CloudEOS instances are still spinning up. So
Okay.
we're waiting for Amazon to finish booting up those VMs. And while we're doing that, I'm going to pop over here to CloudVision. So here I am looking at the streaming telemetry output of one of my cloud edges, right? So this is an edge router that's in AWS that we already deployed, and I'm real-time able to see exactly what's going on with the routing table of that guy.
So what am I seeing here? I see that there's a couple routes.
Yeah, so you see that we've got a couple routes, and those VPCs are still spinning up as we saw on the other dashboard. So the routes pointing to those new VPCs that I'm creating haven't yet shown up here.
Okay, so you're monitoring, oh wait, something just changed.
Yep, so while we're sitting here,
Of course.
you're seeing that now those two VPCs are now online, and those two routes have been populated in real time to my routing table and to my CloudVision monitoring console.
And then what's this historical over here, routing table changes?
Right, so this is the fact that CloudVision runs a time series database, and we're able to go back in time and see every time this routing table has changed throughout the history of this guy being alive. So we can actually see all the times we've run this demo over the last few days.
Just quite a few times, it looks like.
Just a few times,
Okay.
yeah. So we can see every time those routes have been removed and re-added over the course of running this demo over the course of a bunch of days.
That's awesome.
And again, this is all tied into those segment identifiers. So if I select a different one, so let's say we go to the dev one, we're going to see a different routing table output because we've really isolated these different routing segments from one another. So dev is not seeing that 10.6.1 and 10.6.3 that just popped up here in the prod.
So the same dev test prod structure in the cloud is the same dev test prod structure in the network, and it's the same one that appears on-prem.
Right.
This is that global VPC concept, that cloud network private segment concept again.
Exactly, and it's not just in one cloud, it's across all of these different clouds. And as you mentioned, on-prem as well. So here I actually have a CloudEOS instance running in my Kubernetes cluster.
Oh, and that's the Cube 152 over here.
Exactly. So,
Why 152 and why not 42, Fred?
just because that was the last octet of the host that it's running.
Okay.
So our Kubernetes cluster here in the on-prem environment is actually running in the prod segment. And so if I come over here to this guy and I search, my routing table.
Oh, hold on. Kubernetes is also tied in now to the same architecture, the same way you've extended dev, test, and prod for CloudEOS to the multi-cloud. You're now saying you've extended that exact same architecture down into the cloud native environment?
Exactly. So
Don't skip over that. That's really important. I love this. Okay.
So we're actually running CloudEOS on every single Kubernetes node to provide the networking and the routing for those nodes.
And a node is a host, or physical host, or a VM.
Exactly.
Okay.
Yep. And so if I do a search on the routing table of this guy, 10.6, I'm seeing those exact same routes. So, very consistent, very clean. I'm getting the exact routes across all of these different environments. And we've got our reachability now.
And the metric's 0 because they're directly connected routes.
Exactly.
Okay.
Exactly. So now what I want to do is I want to actually play around with that Kubernetes cluster, right? So we've seen how we can kind of dynamically and easily scale things up in the cloud.
And this is down here at the bottom right, is that cube cluster.
Exactly. So
Okay.
so here I have my production Kubernetes cluster, and I'm going to log into the Kubernetes dashboard now. So to do that, we've got to grab a token because we do keep things relatively secure.
You grab a token from Vault?
I grab a token from Vault. That's exactly right. So I'm grabbing a token here to log into my Kubernetes dashboard, and we're going to pull up our Nginx namespace. So we want to play around with our Nginx deployment here in Kubernetes.
Okay.
So we just drop this guy down.
And so Nginx being a web server, and so what you're going to show then, I'm guessing, is like there's some number of web servers running, like 20 or so?
Exactly.
Okay.
Yep. You hit the number on the head. So we're
Because we've done this before.
just a few times. So I'm pulling up my Nginx deployment, and we will see that we're going to have currently 20 pods assigned to this deployment. So
And a pod in this case is an instance of Nginx?
it is an instance is basically a container running Nginx.
Okay.
Yep. So I want to scale this guy up to 30. So let's say we want to scale up our Nginx server to have 30 pods.
And this is something that could happen automatically as well. If a tool is watching the load, it could automatically auto-scale it up or back?
You bet.
Okay.
Yeah, and there's plenty of tools out there that do that. Now you'll see when I told Kubernetes to scale this up to 30 pods, it came back and yelled at me and said, hey, you don't have enough resources to do 30 pods. It'll try its best. It'll probably get up to about 25, 27, there you go. And then it's going to cap out.
So it's run out of server resource. There's like literally not enough server or host or VMs available to run 30 Nginx instances concurrently.
Correct.
Okay.
And so now what I want to do is actually want to spin up some more instances. So I've got an Ansible playbook here that is going to actually provision about 6 or 7 more new Kubernetes nodes into my cluster.
Okay, so you're going to boot more servers.
Exactly. And in this case, every one of these nodes, again, as we mentioned earlier, is going to be running CloudEOS. So we have CloudEOS as the routing stack for every single one of these nodes. So once these nodes...
So CloudEOS runs as a container or container network interface?
Yes.
And then it advertises the addresses it needs to into the routing space.
Correct.
Within one of these cloud network private segments.
Exactly
Okay.
right. Yep. So what I'm going to do now is start spinning these guys up. And if I come back over here to my dashboards, we're going to start searching on the subnet that's assigned to that Kubernetes
That 153 subnet.
Exactly.
Okay.
So I've got 2 right now because there are 2 nodes that are currently up and running in that cluster.
So we're kind of monitoring this now, waiting for that same kind of state change. Do we see the 153 addresses appear in other portions of the network?
Exactly, right. So again, the same streaming telemetry, the same dashboards that I was using to look at what I was doing in the public cloud, as well as the same dashboards, quite honestly, that I could use to monitor my data center network switches, my campus switches. I'm also now able to use to monitor my cloud native Kubernetes environment too. So we're filtering again on 10.153. We've got the 2 subnets, and once these nodes start to spin up, we're going to see this routing table expand just like we did when we spun up things in the public cloud.
There it goes.
So there we go. So we got our first additional node online, the .10, and this is just going to keep expanding as those nodes come online.
So in the background, to kind of recap what you're seeing here, the data that we're seeing as this table fills in automatically, you expanded the number of web servers that you wanted. It hit a threshold of capacity. You ran a script manually that could also be run automatically that expanded the number of nodes available, the number of hosts available to run this on, which then added more server instances. As those new Nginx containers came online and those new nodes came online, their reachability was advertised automatically. It established a peering relationship with their top of rack switch, which then advertised those routes into the network.
Exactly.
Okay.
And we kept it all segregated, so it's in its particular segment, in this case, the prod segment, right? So if I come back over here to the cloud as well, we can see that our cloud edge router as well is also getting all of those routes that just popped up in my Kubernetes segment.
Now there's one thing I've noticed you haven't done here, Fred.
Yeah.
You haven't touched an 80 by 24 1970s era command line interpreter once.
Exactly, yeah. So I've never touched a single bit of Arista CLI in this entire process.
But did the network configuration of those devices comply with the organizational standards for things like AAA and logging, and how did that happen?
Yeah, so it's all done through CloudVision, right? So CloudVision is able to apply all of the compliance things and all of the configuration bits that I need to deploy this in the same fashion that I deploy everything else in the data center and in the campus.
All right. Wow.
And if I, kind of the final checkpoint here is if I go back to the Kubernetes dashboard, you can see the Nginx deployment is now happy because it's got all 30 nodes ready.
Thank you very much, Fred. I hope what everybody was able to see today was an example of using DevOps-friendly tools like HashiCorp Terraform to declaratively provision not just the entire cloud infrastructure, but also the networking infrastructure to support that cloud. An example of elastic billing, being able to buy and deploy automatically Arista CloudEOS instances into that public cloud and then automatically provision them using BGP, EVPN, VXLAN, and IPsec to build an internet scale, reliable, and secure infrastructure. And then using Fred's example of the dev, test, and prod segments, really I believe the first example ever of a global VPC. The ability to have a globally consistent network segmentation model that spans from the campus to the data center to now the public cloud environment, all built on open industry standards. And every one of these nodes, live state streaming back in using Arista CloudVision with live state streaming to be able to debug and troubleshoot and have real-time visualization of the entire network environment. You've seen this deployed in the multi-cloud environment and extending the reach down to the Kubernetes environment. Whereas we scaled up a web application from 20 instances to 30, we then automatically deployed new server capacity to support that, and the network was immediately aware of this with no changes required whatsoever. Again, our goal here is to deliver an amazing operator experience which we now have extended to the multi-cloud and the cloud-native environment. Thank you very much.